Hey everybody, this is Larry. This is me over Q3 of the weekly contest for 15 minimum number of valid strings to form target 1. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So there are a couple of components to know for this problem, and for this problem I mean Q3. We will definitely go over Q4, the harder version of this, but not in this video. We'll have a Q4 video as a companion video if you will, but we'll focus on what you need for Q3 for this problem. Keep in mind that if you're coming from Q4 video, because I would probably be like, oh, you should understand Q3 first. So yeah. The first thing to know for this problem is, you're trying to basically get the for each word, we're trying to figure out where to jump from this one, right? So okay, so let's say that we only have one word. Spoiler alert. Let's say we only have one word and one target, right? Well, we only have one target. Then this is going to be a classic dynamic programming problem, right? So what I mean by that, I'm bringing up the whiteboard. Yeah, this is a classic dynamic programming problem because then basically you have some string, right? Let's say you have, A, B, A, C, A, I don't know, whatever. And then the idea is that, okay, so you have these nodes that are in between each character, and now it's just about figuring how to get from the first node and the last node in the shortest path, right? Shortest path problem. Did I say longest path? I meant shortest path, sorry. Shortest path in a DAG problem, going from left to right. And of course, it's just about drawing these edges in between, right? And how we draw them. And for this particular problem, we have a prefix thing, right? So if we have, say, A, B, D as one of the word, then now we connect A with like this, we connect A and B like this, we connect this, and we connect this, and so forth. So we have more, stuff, right? So so someone like this would add someone like that. We already have a node here, edge here, I mean. So someone like that, and you're just trying to get from the beginning to the end. So this is a very standard problem, and you might see it in Leetcode. There are probably simpler version of this. So you have to know this to kind of solve this problem, which kind of makes it a tough Q3, but, I'm not, it's not up to me, so, But yeah, so basically that's how you set up the problem visually, right? So you have a shortest path in the DAG going from the left to the right. Okay, and then it's about saying on these edges. Of course, if you do a very naive character by character, well, target length is going to be 5,000, right? And each of these words is going to be 5,000. So in length, and then more than one word, but even just one word of 5,000 length, if you try to do like a shift and then count thing, it probably is going to get way up there very quickly with just one word. And with and there are a couple of words, so I don't know if it times out, but it is not looking very good, right? It's something that I wouldn't think about. And so the key idea to solving this then is just figuring out, well, the first part is just figuring out how to calculate the prefix in a fast enough time. And there are really two ways that I would say, the two ways you can, there are a lot of ways really. There are a lot of string algorithms that you need to know, or not need to know, but you need to know at least one or two or three of those very well so that you're able to pull them out. I'm just going to name some here. I think you could use KMP by calculating a failure function and to figure out all the prefixes. Maybe, I don't know, maybe I'm mixing them up. But you can also do rolling hash with like a binary search or something. Because the idea here is that you're trying to see what's the longest prefix that you can get from a current thing, right? And then you just kind of do a binary search on that. Depending to see how far you can get for a particular string. The way that I end up doing is this thing called Z function. Use Google or ChatGPT, I guess, to explain it to you. I'm not going to go over Z function here, or at least the implementation of it in detail. honestly, I'm not gonna lie, I don't know that much about Z function. I don't know how it works, honestly, that well, but I've seen it enough times that I know how to use it, and that maybe is good enough. And the way that you use it actually is very similar to how you use a suffix tree or something like this, or suffix array, actually. But yeah, the idea here is that, okay, for each word, and this is the Z function if you want to take a look at it. Again, I copied it from ChatGPT, so I don't know how it works, but the key part is that if you use a word, you're going to do something like this thing, right? So for a word and the target, and so Z function, what is the way to say it? Okay. So this is from ChatGPT because I don't want to mess it up. Like I said, I don't know this one that well. But yeah, for each index I, the value of Z sub I, okay, for each index I, Z sub I gives the length of the longest substring starting from I that matches the prefix of S, right? So from this, for example, you have ABC, and your target is ABCD, ABC, ABCDE, or something like this, right? So then now, the thing is that if you run this Z function by adding a pound thing, or really anything that doesn't exist, I always use a pound just from my, sometimes I use $, I guess, from my old days. But yeah, but then now because nothing will ever match the pound, but now what that does is that for each one we match, okay, well, this goes to 3 here, this goes to 0, this goes to 0, this goes to 0, this goes to 3. I guess that's very coincidental, actually. Why do I keep on repeating it? So if we move a C, then this is 2. Yeah, and then maybe if you have like AA, then this is 1, 1, and yeah. So this gives you the longest substring starting from I. So that means that given the word ABC, we are able to go from the beginning of this to end of this, right? So that's basically the idea of drawing these edges. Okay, so that's how I set this up. And this code is actually pretty short, as you can see. Because E is just the number of edges, and here we want to see how far we can get from this index, which is why we have max. So now, so we enumerate, we call the set function. Set function actually compares it with itself. So if you have, oh, where did this go? If you have this, actually also gives you answer for like the beginning part, which is why I chopped this off. And once I chop this off, it will give us this array, and then we just go one character at a time, right? From the 0th index, we can go 3 forward, 0, 0, 3, and so forth. And now we just keep track of how far we can go from each index, updating it to the max. Why? Because that's the furthest that you can go, right? Because keeping in mind that for this problem, it is a prefix thing. So for example, if x is 3, that means that you could go 1 step, you could take 2 steps, or you could take 3 steps, right? So that's basically the idea. And now you have the shortest path in the DAG problem for the rest of it, which is that, okay, so then now, yeah, so we set this up as infinity. We set base case of 0 from the node that's before 0, and then now we just go forward, keeping in mind that there's n plus 1. Yeah, and if this is reachable, that's what the infinity means. If this is reachable, then we just do a loop on the x, and we just basically update, okay, what happens if we do 1 step? What happens if we do 2 step? Or we update for 1 step, 2 step, 3 step for the minimum distance. And then at the end, if it is greater than infinity, or I don't think it should be greater than, but that's the way I always write it. Or maybe not always, but very often. Then we return -1 because it's not possible. Otherwise, we return this number. Yeah, and that's basically it for Q3. So what do we have here, right? So the key part about this thing is that Z function is linear. So instead of, so if we have a word of 5,000 target and 5,000 is a word, then it's actually 5,000 plus 5,000. That is the magical part about this that makes everything work. So this is kind of, let's say we have, W words, right? Yeah, and each word is M length or L length. Then this is going to be O of W times L times N, right? Time, roughly speaking. Of course, there's some caveat here with the W times L because, as they say, it is the sum of the length will be less than or equal to 10 to the 5th, so you should be good enough. And then this one, this is O of N, and this could be O of N as well every time because X, you can imagine the worst case is everything is an A for both the target and the words and everywhere. And in this case, then this updates each of them individually for each cell. So this is going to be N squared. And yeah, so this is N squared in general. So, and that is probably the expensive part. In terms of space, this is linear space. This is linear space. I guess this is linear space. But yeah, so everything is linear space. And yeah, that's all I have for this one. That's all I have for Q3. For Q4, this is too slow. We have to do an optimization. No spoiler alert. Check out that video. But that's all I have for this one. And you can watch me solve this live during the contest now. Oh, wait. Before I go, so I did get a wrong answer on this one with a 5-minute penalty. It's because I didn't have this for loop. So I thought that the way that I wrote it the first time, I just kind of misunderstood it. Or I rushed it a little bit probably as well. Is that, yeah, when for example, if this number is a 5, I just jumped 5 steps. I didn't think that you could do 1, 2, 3, 4, 5. I didn't code it that way anyway. So, which is honestly very silly because that is what the problem keeps telling you. But yeah, anyway, that's all I have for this one. You can watch me solve it live with that error next. If it times out, I'll be sad, but it shouldn't time out. Okay. Whew. Okay, what's the difference between these two? The problem looks the same. N is the same, but the word lengths are a little bit longer. And the target is a little bit longer by 10. Okay, let's take a look. Let's read the problem. String X is core value if X is a prefix of any. Okay, return the minimum valid string type we can candidate to form target. If X is valid, okay, yeah, that's what I thought it meant. It's just DP. There are only 100 words. Z thing. To it. People already got submitted. Okay. This is the only thing that I always have to look up, the Z function. I actually don't know how to use it, but so we have 100 string target. So it is going to be. Is this fast enough? Let's see. So we have, what's that? 5. Is it 5,000? 5,000. So 2 of them is going to be 10,000. 1 million should be fast enough. It may not be fast enough for Q4 though. Q3 should be good. How does this work again? Whatever. Forward in words. Oops. It's either way. Yeah, it's, I know it's either one or the other, so it's fine. Okay, so 1, 3, so yeah. So is it the other way? Does it matter if it's the other way? Maybe not. No, it's definitely the other way. But this is the prefix. Okay. So then now we have to see function. We want to get basically the length of the word plus 1. People already got it. I'm not that surprised. So okay, so this is the prefix that we care about, right? And then we just want dp over all of this. It's at minimum and -1. Okay. How many things are there? So there are 5. So 5,000. So they're all good. Right. 5,000 squares a little bit slow though, isn't it? People haven't gotten that one yet though. People have gotten this one. 5,000 square. This Leetcode stuff. Maybe I need to convert it to Java or something. Alright, so then now okay, so then now we have all this stuff, right? So okay. Okay, so we have this array, right? Okay, and then now we have maybe something like yeah. 2. So we have 1 for each word. No. We have 1 for each length. And then now we have for index x and enumerate this. If x is not equal to 0, then e of index append x. Okay, that looks kind of right. Maybe. Okay, so then now we want dp, right? I'm not surprised we got this quickly. I know I'm taking my time to be careful, but I think I want n plus 1. Right. So that's the delta. Then dp of x plus. Okay, so if dp sub I is less than infinity, x plus I is equal to min of dp sub I plus 1. And yeah, and dp of x plus I, I guess. And then now we just return, if dp of -1 is otherwise return dp of -1. I think this is fine, maybe. Is it fast enough? I don't know. Let's try. Words is equal to a times 5,000 times 100, and target is equal to a times 5,000. I know I'm taking my time on this one, but okay. I mean, not super fast, but not super slow. That's okay. We'll see. Someone says not wrong. Ah, man. Output 9, expected 8. What am I doing wrong in this one? Output 9, expected 8. Am I off by 1? Maybe I'm off by 1 somewhere. Okay, so here is in from 0. We want to take 2. Okay. Oh, I see. You could take 1. So actually, you don't have to take all these steps. So then you get max. Okay. Okay. That makes sense. So then now instead of this, we want actually, okay. Okay, I did it wrong. Okay, and then now this is for I in range of use I plus 1. Oops, for X. Okay, so this is right, but is it fast enough? I gotta stop deleting this stuff. Okay, so words is equal to target is equal to I know I could randomize it, but I think this is good enough for a worst case analysis. 5,000 square. Is it too slow? Apparently it's too slow, which I expect because this looks ridiculous. How do I fix it? I mean, if we look at it backwards, then now we're updating it, looking at back and then the last 5 items, right? How many people got this? Am I doing it weird? I mean, probably, but this is just n square, right? Or is this like a Java, Python thing? Let me see, convert to Java, please. maybe Java is fast enough. I mean, I know that I can make an optimization, but I just want to get this one in first. And I'll also be very sad if the Java works, just because, you know. Infinity is equal, okay, that's probably fine. I forget if that's the thing. What line is this? 66. Oh. Did ChatGPT just cut off? No, but I also don't need this. So, okay. Where? Line 7? What? It should be that length, but I don't even use it. Okay, and then now let's try words is equal to does that work? I forget how to say things in Java. Okay, let's just say target is equal to for whatever, this is fine, right? And then for words, is that right? 100. Okay, that's fine. For this is so silly doing this, but it's okay. Is this fast enough? Looks fast enough. Is this a Python thing? Maybe it is. YOLO. I hate Leetcode. How am I doing? Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, this explanation, everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.